In 2018, Shizuoka University had made an experiment, and on the behalf of that experiment, Japan will start this program of space elevator. Obayashi Corporation of Japan is engaged to launch a space trip program. With this elevator, people can reach a height of 96,000 kilometers from Earth to space. The space satellites will be used to construct a space station in the space for this elevator. The company claims that the construction of a space elevator will start from 2025 and it will be fully functional by 2050. The company claims the carbon nanotubes will be used in this space elevator, and these carbon tubes are more rigid than the steel.
This is pre-space and this was post. This is an entire new society. Everything changes.
Imagine simply climbing a cable into space. No rocket. Just press the up button and you're there. The concept is known as the space elevator. Not only could it significantly change how we leave planet Earth, but it could also completely transform humanity's relationship with space. And there are scientists who think we could have already built it. Ideas of a space elevator type device extend as far back as the 19th century, but these ideas struggle to advance beyond the realms of science fiction, as we continue to rely on tried and tested methods of getting into space.
Right now we've got rockets. They use a lot of fuel. They take a lot of fuel to get up into space. They have to carry fuel to lift the fuel to lift them into space. If you want to go to geosynchronous orbit, it's millions of dollars per pound if you want to go to the moon or Mars. It's expensive. With the space elevator, we reduce the cost of getting into space to dollars per pound.
So how does the space elevator even work? The basic idea is a cable would be pulled taut thanks to a counterweight. It stays vertical because the counterweight is thrown outward by the Earth's rotation and the base is held down by gravity. Early ideas suggested building a cable from Earth up into space, but the materials needed to withstand such enormous weight don't exist. Physicist Bradley Edwards breathed new life into the theory.
I've been working on the space elevator along with a number of other space systems and new technologies for the better part of 30-some years. I searched for years to find a reason why we couldn't build a space elevator. There was no reason.
The problem with earlier versions of the space elevator was we just didn't have a way to build the cable that was needed to maintain a space elevator. And Brad came up with an innovative twist looking into the future on where carbon nanotubes might go in terms of strength.
Carbon nanotubes are something of a super material. Despite their tiny size, they're theoretically stronger than things like Kevlar or graphene. Brad Edwards suggested launching a rocket which would carry the carbon nanotube cable. One end of the cable would then be dropped back towards Earth. The cable would be light enough and strong enough to build just a thin ribbon which robots could climb to build more ribbon, eventually becoming strong enough to carry heavy payloads, such as solar panels, satellites, and even tourists. So what about the cost of carbon nanotubes? Is this the biggest hurdle?
Literally, in our system, it costs us about $1 a gram. And we need about 1,000 tons to build the first space elevator. But when you talk about building the space elevator for a total of $8 billion. We easily spend that money launching satellites. It's not that expensive.
There's an estimated 128 million objects smaller than a centimetre orbiting the Earth, along with another 900,000 that measure 1 to 10 centimetres, all with the potential to cause significant damage. Brad Edwards' concept would see a space elevator mounted to a mobile oil rig-like structure to dodge any dangerous material.
It's really hard to imagine that you could have a space elevator that could survive the number of collisions that one would expect over the lifetime of a space elevator. And, you know, if the ribbon's cut, you're having a bad day.
Again, we're talking about a ribbon, 3 feet wide, thin as paper. If you break the top part off, the counterweight, what happens is the ribbon starts to come down, it breaks at the bottom, and the entire ribbon flies out into space, never to be seen again.
I would love to be proven wrong. If we had a space elevator, it would be awesome. It would be paradigm changing.
We can colonize the moon, the Mars. We can go to the asteroids cheaply, and we can mine them for minerals, metals that we're running out of now here on Earth. It's changed from back in 1998, it was science fiction, you know, capturing asteroids, bringing them in, building large cables. And now we have it. And we probably could have started building it 10 years ago.